The Cobb-Douglas utility function is one of the most common utility functions used in economics. In this set of graphs, we'll explore some of the types of indifference maps that can be modeled with this function. You can also explore this further in one of the modules that's presented in the Exploring Relationships tab on this website. In the two-good case, the Cobb-Douglas utility function takes the form x1 to the alpha, x2 to the 1 minus alpha. And in panel A, we present the indifference curve that's generated with this utility function when alpha is set to 0.3. In panel B, we present the indifference map that's generated by this function when alpha is set to 0.5. And in panel C, we set alpha equal to 0.7. Now notice that when alpha is 0.7, 1 minus alpha is 0.3. Thus the x2 good in panel C is treated the way the x1 good was treated in panel A. For this reason, the indifference maps look kind of similar, except that in panel C they converge more quickly to the horizontal axis, whereas in panel A they converged more quickly to the vertical axis. Now consider the role that alpha plays in the Cobb-Douglas utility function. If alpha is less than 0.5, it tells us that the consumer places relatively less weight on x1 goods and more weight on x2 goods. In panel A, for instance, the consumer can reach the magenta indifference curve in various ways. If the consumer gets a lot of x2, it doesn't take a whole lot of x1 to reach the magenta indifference curve. But if the consumer doesn't have a lot of x2, the good she values more, then it'll take a lot of x1 to make up for that. The reverse is true in panel C. In panel B, alpha is 0.5, and so the consumer places the same weight on each of the two goods. As a result, the indifference map is symmetric around the 45-degree line, because both goods are treated symmetrically by the utility function. When alpha is less than 0.5, on the other hand, as it is in panel A, the ray from the origin along which the marginal rate of substitution is equal to -1 lies above the 45-degree line, and in panel C, where alpha is greater than 0.5, it lies below the 45-degree line. In this sense, we could say that the whole indifference map that's generated by a Cobb-Douglas utility function is tilted away from the 45-degree line and toward the axis of the good that has a higher exponent. Still, it's true that for any Cobb-Douglas utility function, the elasticity of substitution is equal to 1 everywhere. So the elasticity of substitution being equal to 1 is consistent with lots of different types of indifference maps, and lots of ways that consumers can consider some goods more important than others.